So we're starting chapter 12 with tangent lines, and tangent lines, lines that touch a circle at only one point. It's got it labeled there for you as a definition, and again, as you're going through these notes, you can pretty much just pause, write these down on your paper. You can rewind it if we're going through some of those problems. You want to try those again. But starting with those definitions, again, we're starting with 1 point for a tangency. This would be your point of tangency. That's when the tangent and the circle intersect. So again, you would call something like this, BA is a tangent ray. I start at that point of tangency, I go out towards A, that'd be a ray. Could also call it a tangent segment if I just go from B and stop at A. Just looking at that point right there would be a tangent segment. It's also describing radius of a circle, tangent that intersects the endpoint of the radius on the circle have a special relationship. Getting that with theorem 12.1. Line is tangent to a circle. The line is perpendicular to the radius at the point of tangency. So basically that perpendicular part, again, that's going to be important when we're forming our questions with this. If I start again with AB, this is my tangent line, tangent to that circle O, and we can call it by that center, and that's the point of tangency at P. If I use that, just that tangent line, I know that it's going to form a perpendicular with the radius. So OP is a radius, AB is the tangent line, and those two we can see are perpendicular. So as we get into these questions with our first problem, basically what you want to do is try and do as much of these as you can by yourself. Again, these notes are already written out ahead of time, so what I would suggest, maybe look at this first one together. When I get down to that second one, maybe try it before we get to it, but you can always go back, rewind these, and see if you can look at the description again. But looking through problem one, again, I have it written out already with the solution, but let's see if we can just walk through it. If ML and MN are tangent to the circle O, we have to figure out X, basically by using what we just referred to in that last theorem. So if I use ML and MN both as tangent lines, remember those are both going to be perpendicular to the radii that I have here, OL and ON. So if I use those two as right angles, if they're perpendicular, it's also give me 117 is that central angle of that circle. And to find X, all we have to do is remember that if I have four angles, that's going to be a quadrilateral, I know that's going to add up to 360. And that's where I get my formula. If I take the 117, add angle L, add angle N, so these two angles right here, we know those are both 90 using our tangency fact. And if I add all those together, I solve for X, I get that the missing measure for that quadrilateral has got to be 63. So if I try that again, and again, see if you can do part B before we get to it. But just looking at part B, again, go ahead and pause it, see if you can solve this first. But if I'm looking at a triangle this time, it's really the only difference. I still have a tangency line DE, or I guess we call that segment DE, and we have OD would be your radius. So if I know those are perpendicular, I know there's going to be a 90 there, 38 is listed, X is that last missing angle, but now since I have a triangle, it's not equal to 360, add those up, we get 180, and X, that missing angle, should be 52. So looking onto that second page, and again, feel free to pause, rewind if necessary. Trying to work this out with a word problem. So we have a tower in Toronto going 447 meters above ground level. Want to figure out how far it is from the observation deck, and you want to add this into there. Should be to the horizon, so observation deck to the horizon. And it's also giving us the Earth's radius, but basically everything I need is listed kind of in this figure they've drawn out. So we've got the Earth, we've got the radius from the center of the Earth out to the surface. And one of it's labeled 6400, but remember if I take another radius that's still 6400, if I want to figure out the distance from the top of the tower to the horizon, that should be this distance here from T to E. So if I want to figure that out, I labeled this as X, that's what we're trying to find. We know the height of the tower, which we've rounded to 0.45, remember that was 447 meters. If I want to figure out that tower's distance again from the top to the horizon down here, I could use Pythagorean Theorem. And the way we're going to use that is we're going to use X as one leg, your radius as another, so X squared plus 6400 squared equals both the radius and the tower's height put together. So radius of the Earth is going to be much bigger in this case, 6400, plus 0.45 for that tower. If I complete that with Pythagorean Theorem, we can see that we're working through our steps, solving for X. Eventually we get 75.9 for X. So again, I could put that in terms of Pythagorean Theorem. All I got to do is plug in some parts. X is what I'm trying to find. 6400 can work both for one leg and part of the hypotenuse. and I plug those in, should get my answer for x. And moving on to our next theorem here, if I have theorem 12.2 saying that if a line in the plane of a circle is perpendicular to a radius at the endpoint of the circle, we know that line is tangent to the circle. So again, kind of just like going backwards from what we had before. Last time we said if it's a tangent line, then I know they're perpendicular. This time, remember, it's like a converse. If I say they're perpendicular, that tells me that it's a tangent line. So it's not really labeled as a tangent line, but if I know that these two are perpendicular, I know that AB is going to be tangent. So we can use that forwards and backwards. So trying that with some examples, again, feel free to pause if you want to try these independent. But trying to find the circle, radius of the circle, means we're looking for this distance x, which I've been kind enough to give you a variable for. We know that there's going to be two parts labeled, so 12 for one, 8 for the other, and we're still using Pythagorean Theorem. Basically just using the fact that if I have a tangent, that's a right angle. So if I do 12 squared plus x squared, those are my two legs, that's going to be your hypotenuse squared. We've got to be careful of for the hypotenuse though, it's not 8x. You're going to have x for part of it, 8 for the other. So think back to when you're doing 6400 plus 0.45, adding those two parts of the hypotenuse together, and that can complete the Pythagorean theorem. X squared plus 12 squared is hypotenuse squared. And for this, we just got to make sure that we're solving for x. We can expand this part, x plus 8. If I square it, I get this trinomial. I can cancel out the x squareds, subtract over 144, or even you didn't really have to. You could subtract 64 over to this side. We eventually get our solution for x. We get 5. So same kind of idea on the next one. If I take those two x's, just got to make sure we set up 10 squared plus x squared. That's going to be your entire hypotenuse squared, so I make sure to do x plus 6. And if I square those, I can, again, this time I didn't get a 0, I just made sure to subtract 36. Divide by 12, we get our solution for x. So just make sure that if we're using that Pythagorean theorem, important part there is to look at the hypotenuse as two of those parts put together. And let's look to that last page. So if I'm trying to figure out if ML is tangent to the circle, then again, basically I'm just using what we already had, Pythagorean theorem, but I'm using it to verify. If 7 squared plus 24 squared equals 25 squared, that tells us that we have a right triangle. So we didn't have that right angle first at the beginning, but since I can verify that this works from Pythagorean theorem, I didn't really multiply it out. I'm not really sure what those are both equal to, 625 or something like that. But yeah, if I multiply those out so that Pythagorean theorem works, 7 squared plus 24 squared equals 25 squared. If it's a right angle, I know it's got to be a tangent. So that's using our last theorem that we just saw. And last rule that we're going through is finally not looking too much at right angles, because if I look at AB and BC here, we don't really care too much about the radii that it's forming. But this rule is saying that if I have two tangent segments have a common endpoint outside the circle, in this case that common point is B, I know those two segments are going to be congruent. So that's what we have here. We have AB, BC, both tangent to the circle. They both include this endpoint B, so I know that the distance from B to A should be the same as the distance from B to C. And again, we're going to try that in those examples in a sec. So let's describe first. Difference between inscribed and circumscribed. Circle is inscribed in the triangle, means I write that inside, so think inside inscribed. And circumscribed means I'm going all the way around that circle with that triangle, so that's going to be circumscribed about the circle. So trying basically our last theorem with our couple of practice problems here. If I'm labeled just with the 10, the 8, and the 15, they're only labeled once for each. We're basically using this to get a perimeter of that triangle, so the triangle goes all the way connecting those three endpoints outside the circle. We're using the fact that if I know the distance from A to D is 10, the distance from A to F will also be 10. So same endpoint, same distance, 10 and 10. I use that rule here again, 15 and 15, 8 and 8. Those are both using the same endpoint and they're both tangent. Add all those up, we get the perimeter of 66. So same idea with that next one. Again, go ahead, see if you can try it before we get to it. But looking at that one now, if I have a perimeter of 88, now we're just kind of going backwards. We're not finding the perimeter. We're finding a missing measurement here. If I don't know OX or OY, or sorry, that's a Q, so QX, QY. I'm using the same fact. If I'm going from 15 from P to X, 15 will also go from P to Z. 17 from R to Z means that 17 will also go from R to Y. add up all of what I know, and I can find that two x's that are missing, so from q to x and from q to y, those are your missing parts, but adding up all the other ones should get us our total perimeter of 88. So I just got to solve that for x, and we get our solution. So make sure you have these notes filled out. Again, feel free to go back, look it over, see if there's anything else you want to fill in. Come prepared with questions, bring your work, and yeah, we'll get this covered in class.